Let's take a look at the solutions to the review for exam 1, the second part. First, derivatives from tables. This goes all the way back to before we did actual derivative properties and rules. And so we were looking at this as a rate of change. You're approximating, you can't do it right here, so we take a point on either side, and this is the point 5,2, this is the point 15, 16, x is 15, y is 16, or t in this case. We find the rate of change, which is slope, folks, between these two. And then from there, we can name that as the approximate derivative of t at 10. So we do 16 minus 2, that's the difference in the y's. 15 minus 5, that's the difference in the x's. And simplify. And that's all you have to do is rate of change, which is slope. If you're doing it at 1, you take on the other side. So if you're doing it at x is 25, you're going to use this column and this column. For the next one, you're sketching a curve, and you're going from left to right. Remember, rates of change are per unit. And so this 3, when it says -3, it's really -3 over 1. And you're going from 0 to 2. So you bunny hop 1, go down 3, bunny hop another one, go down 3. And so if we start at sticks, we go down 3 to 3, go down 3 more to 0, and we end up here. You can do the line anywhere. What I recommend is pick a point, mark where your ending is, and then just draw a curve in between. For the next one, the rate of change is 2 from 2 to 3. Well, that's a single bunny hop, so we're just going to go up 2. I made a straight line here. You could have gone up, way down. We'd be off the graph. I'd recommend you stay in, so you could go right up, make it whatever you want up there. And then from 3 to 5, there's going to be 2 bunny hops, 3 to 4, 4 to 5, and we have to go up 4 for each one for it to be an average. So up 4, up 4. So if we start here at 2, that's the y value, we need 4 and 4, that's 8, so we're going to end up here at 10. So you put a dot there, and then you connect these guys. You can make it a straight line, you can come down and then up, you can do squiggle, 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 and there. As long as the y value goes from here to here, which is a rise of 8 over these two, up 4, you're good to go. Let's look at antiderivatives and indefinite integrals. Remember, these are reverse power rules. Here, we're asking ourselves whose function has this as a derivative. So we're going to add 1 to the exponent, -6, divide by the new exponent. That's because when we take the derivative and go backwards, we use the power rule, bring the -6 down, divides out with this, subtract 1 from the exponent to get -7, and you're good. And so you're really verifying this way antiderivative, this way derivative. Don't forget the c, because we don't have an initial value. We're going to do that in a minute. And you need the whole family. And so let's do this again. This guy, because he's got an exponent of 5, looks like we have to use the power rule, but he's in the denominator. So you have to rewrite him with a negative exponent. Now we can use the power rule. Add 1 to the exponent, get -4, divide by the new exponent. Let's take the derivative to go backwards. Bring the -4 down, divides out to get 1. -4 minus 1 is -5. Cha-ching, plus c, because it's the whole family. For this guy, you're asking yourself whose function has a derivative of 2? Whose function has a slope of 2? Well, whose function has a slope of 2 is all linear functions, and so you get 2x. Take the derivative to go backwards. What's the derivative of 2x? Just 2. Don't forget the c. Initial value problems. Find the function f. So your final answer is going to be this function. And to get there, when they give you the derivative, you have to first use the integral sign. You can't just magically appear with this. You've got to write integral of the derivative that was given, dx. This is what tells you you're allowed to go to here. So just putting this as if you took angel wings from here to here, you got to have the integral sign of dx. You can't just magically go from there to there. This gives you the right to do that. Now take the derivative to check. 2x minus 4, great. Don't forget the c. We need the function. They gave us an initial value. F of 1, 5, x is 1, y is 5. So you can write the point 1, 5 here if that makes you feel better. Y is 5. X's are 1. Excuse me. Go ahead. 1 squared is 1, minus 4 is -3. Add 3 to both sides to get 8. here you have 8. Put it in for here. Don't forget to name it f of x. Find the function f. That's the function f. And there he is with c that we found. Now, profit, revenue, and cost. This is an application problem. So a company determined the marginal revenue. Remember, that's a new term. Marginal revenue is just the change in revenue, which is the derivative. That's why it's written as R prime, from selling the X unit of a product. They give you the derivative. They also say, given the revenue from selling 0 products is 0, find the revenue from selling 30. So we're going to have the revenue function. Then we're going to have to substitute in 30. So we're going to have to do this, but to do that we need the function, which means we have to come take an integral because they give us the derivative. So we're working backwards when you see a problem like this. As soon as you see R prime or C prime or P prime, and they tell you you need to use the original function, you need an integral. So you take the integral of this derivative, whose function has a derivative of this, x cubed over 3 minus 3x, take the derivative to check, bring the 3 down, divides out x squared, take the derivative, you get negative 3, c, because it's the whole family at this point. Now we need the initial value. Don't forget, put little lines. You're working left to right, column, 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 with little lines, so I can follow along with what you're doing. And given that the revenue from selling 0 units is 0, so that's the initial value given in words instead of in a table or in function notation like they did here. And so we put the zeros in, and whenever they're giving you it for 0, the y really is the c. And so we get this function without the c because the c is 0. Now we have to find the revenue for selling 30 units. You're going to put 30 in here and cube it, divide by 3, minus 3 times 30, and you get 89.10. The revenue from selling 30 units. And so don't forget to name what it is that you found. That's it. Hope you're having a great day.